Hello and good day everyone. Welcome back to my YouTube channel. My name is Sir Marcy and our lesson for today is all about transforming quadratic function in general form to standard form. Okay, let's now differentiate first what is the general form from standard form. The general form of quadratic function is that it is in the form of y is equal to ax squared plus bx plus c, while the standard form is in the form of y is equal to a times the quantity x minus h squared plus k, where the h and k here stands for the vertex, and the vertex is the turning point of the parabola. Alright, let us now transform quadratic functions from general form to standard form. To transform a quadratic function from general form y is equal to ax squared plus bx plus c into standard form, consider the examples below. Example number 1. We write f of x is equal to x squared minus 6x plus 14 in the form f of x is equal to 8 times the quantity x minus h squared plus k. So step number 1, group together the terms containing x. So in our example, we have f of x is equal to x squared minus 6x plus 14. We will group only x squared minus 6x. That is why it is closed in a parenthesis. Next step is we're going to factor out a. Here, a is equal to 1. So from our quadratic function, we know that the value of a is 1, b is negative 6, and c is equal to positive 14. So to factor out a, we will divide all terms containing x with 1. So x squared divided by 1, we have x squared. Negative 6x divided by 1 is negative 6. Then plus 14. Next step is we're going to complete the expression in the parentheses to make a perfect square trinomial by adding a constant. Okay, so if we have here f of x equals to 1 times the quantity x squared minus 6x plus blank plus 14 minus blank. Remember, whatever number or value we add here must be subtracted here. Okay, so to make this a perfect square trinomial, we will just simply get half of the second term, which is negative 6 times 1 half, and the answer is negative 3. After we get half of the second term, we're going to square it. Negative 3 squared is 9, meaning to say we're going to add both sides of the equation by 9. Remember also that if we add 9 here, we will multiply it by our a here. So that's why we have negative 1 times 9. Then we simplify the expression and express the perfect square trinomial as a square of binomial. To do that, we're going to first simplify the equation. We now have f of x equals to 1 times x squared minus 6x plus 9 plus 14 minus 9. That's now equal to 1 times x minus 3 squared plus 5. How did we do that? First, we get the square root of our first term, and that is x. So the square root of x squared is x. We copy the sign of the second term, that's why it's negative. And then we get the square root of the last term, which is 3. Then raise it to the second power. Also, we simplify 14 and 9. So 14 minus 9, the answer is 5. This is now the standard form of quadratic function. So remember, in general form, that is f of x is equal to x squared minus 6x plus 14. If we're going to transform that to standard form, that is now f of x is equal to the quantity of x minus 3 squared plus 5. And to get the vertex, that is simply get the opposite of negative 3, which is positive 3, and then copy positive 5. So this is now the vertex, and that's now our answer. Okay, let's now proceed with problem number 2. Transform f of x is equal to 2x squared minus 4x plus 4 in the form f of x is equal to 8 times the quantity x minus h squared plus k. Step number 1, group together the term containing x. So in our example, we have f of x is equal to the quantity of 2x squared minus 4x plus 4. We group the term containing x, and that's the first term and the second term. Next is we're going to factor out a. Here a is equal to 2. From our example, the value of a is 2, b is negative 4, and c is positive 4. If we were going to factor out a, that means we're going to divide the first term by a, we have x squared. We divide the second term, negative 4x, by our a, which is 2, then we have negative 2. Our answer now is f of x is equal to 2 times the quantity x squared minus 2x plus 4, since we factor out a, and that is 2. Next is we're going to complete the expression in the parentheses to make it a perfect square trinomial by adding a constant and also subtracting the same value from the constant term. So here in our example, we have f of x equal to 2 times x squared minus 2x plus, we're going to place a blank space here, plus 4 minus blank. To make it a perfect square trinomial, we're going to get half of the second term, which is negative 2 times 1 half. The answer is negative 1 squared, and negative 1 squared is equal to 1. We're going to add this to our to make it a perfect square trinomial, and we're going to multiply it. We're going to subtract it by 2 times 1. Since we have our a here, 2 multiplied to our constant term, we have now negative 2 times 1. And we're going to simplify and express the perfect square trinomial as the square of binomial. It means that we're going to simplify the equation. That's now 2 times x squared minus 2x plus 1 plus 4 minus 2. And we're going to make it a square of binomial. We're going to get the square root of the first term. We have square root of x squared is x. Copy the sign of the second term and square root of our last term, which is 1. And then we simplify this part. So we now have f of x equal to 2 times x minus 1 squared plus 2. Okay, so that's now our answer. So, if you remember, the general form of the quadratic function is f of x is equal to 2x squared minus 4x plus 4. And the standard form now is f of x is equal to 2 times the quantity x minus 1 squared plus 2. And if we're going to get the vertex, which is the turning point of the parabola, that is now positive 1 and positive 2. Okay, there is also another way of finding the vertex and transforming a quadratic function to vertex per using this simple formula. Okay, so this is method number 2. Using the same example, number 2, we're going to transform this in the form f of x equal to a times x minus h squared plus k using the formula of the vertex. So to find the vertex, we use this formula. For h, we have negative b all over 2a, and for k, that is equal to f of h. First, we're going to identify the values of a, b, and c. So from our quadratic function, a is equal to 2, b is equal to negative 4, and c is equal to positive 4. Next is we're going to solve for h by plugging in these values in our formula. H is equal to negative b all over 2a. So we now have negative times negative 4 all over 2 times 2. When you simplify this, we have 4 all over 4. And 4 divided by 4 is equal to 1. Therefore, our h is equal to 1. After we solve for h, we will plug in this in our k. So to solve for k, we will now have k is equal to f of h. And we know that h is equal to 1. Therefore, we now have k is equal to f of 1 is equal to 2 times 1 squared minus 4 times 1 plus 4. If we simplify it, we now have 2 minus 4 plus 4. Simplifying this again from left to right, we have negative 2 minus 4, that is negative 2 plus 4. The answer is positive 2. The value of k is 2. So we now have the vertex, which is in the form of h and k. If we will substitute this, our vertex is 1 and 2. So this is the turning point of our parabola. Next is we're going to rewrite the quadratic function in standard form. Remember that the standard form of the quadratic function is f of x is equal to a times x minus h squared plus k. We will just substitute the values of a, h, and k. Then we now have our answer. F of x is equal to 2 times x minus 1 squared plus 2. That's all for now. Thank you for watching, and please don't forget to like and subscribe to my YouTube channel.